Alright, hello, this is Mr. Martine recording a video for you on transformations. And they are more than meets the eye. Hope you enjoy that reference. Today we are going to be talking about several types of transformations. There are four main types: translations, reflections, rotations, and dilations. I want to focus on today with this video, translations and reflections. In our next video, we'll talk about rotations and dilations. So, since the Rams just beat the Buffs, I'd like you to get your green on as we talk about translations. Translations moves a figure on the plane. And that's just a simple way of saying it picks itself up and it moves itself over. It can be horizontal, which is the form the x-coordinate plus some a value. It can be vertical only, which would be the y-coordinate plus some h value. It could be some combination of that, which would be of the form take whatever the x-coordinate is, add the a value, and take whatever the y-coordinate is and add the h value. So basically just taking the horizontal and vertical and putting them together. The movement is referred to as a vector, and a vector is kind of an interesting type of term. You'll hear a lot about it in physics. But a vector, you can basically think of it like the wind. Several of the news channels now are showing vectors when they're talking about wind. And so the wind just kind of blows itself around and blows the objects around in the same way that the translation vector will blow your object about the plane wherever it wants it to go. Okay, so we'll get our green on over here for a while and come and think about this. Each point for the figure is moved the designated distance, which is indicated by the vector. Since each point moves according to the designated vector, the distance and the measure of the angle is preserved within that figure. That means that the transformed figure, the translated figure, is perfectly congruent to the original figure. And that's an important point of translations. Any type of transformation which preserves distance and angle is called a rigid transformation. We'll talk more about rigid transformations in a little bit. And yes, we beat Colorado. Aren't we so proud? All right, notation-wise, this is important. The letters that name each point in your figure continue to that translated figure. And now there's an apostrophe after them. That apostrophe is called a prime. So if I had triangle ABC and translated it, I would now call it triangle A prime, B prime, C prime. If I chose to then translate triangle A prime, B prime, C prime, it would become A double prime, B double prime, and C double prime, which would just look like two apostrophes after that figure. And I think you get the pattern from there. All right, let me take a moment here and show you exactly what we're talking about. So I have triangle ABC right here, and I've marked a translation vector, and we're going to go this distance from here to there. And so if I select all of figure ABC and choose to transform it by a translate object, I want to, let's do that first, transform and mark that vector. No, let's do that. Mark that vector, there we go, and it marked it for us. And now I grab this figure and I want to translate it by the marked vector from this point to that point. Then notice I get my pre-image right there. I'm going to go ahead and translate it, and it shows up. Well, let's figure out what it named it here. Oh, look, A prime, B prime, C prime. So it did follow that notation measurement there, and we could, if we wanted to, have called this triangle CAB, and now this would be triangle C prime, A prime, B prime. The order in which you name them isn't particularly relevant, although you want to be consistent with your order and go in the same way that you went with for your original figure. Now, take a look at this. As I don't want that here. As I move my original vector, then the figure in which I have translated also moves. So as that vector changes, the movement from my original figure to my transformed figure follows that vector, which is pretty important. Okay, I also want to notice something here. I want to show a few things. No, I don't want to show a few things. I want to connect these points. And we'll splay it with a dashed line here. I want to connect these points. There we go. And I want to connect these points. And I want to grab this translation vector and notice how it is perfectly congruent to the distance between C and C prime. It is perfectly congruent to the distance between B and B prime and between A and A prime. And if I drag this perfectly along those segments, not easily done with a mouse, but you get the idea, then you notice that the set of points that makes up each segment has been translated according to that translation vector. And that is exactly how a translation moves. And it also gave me kind of a cool perspective drawing of what now looks like a triangular prism. But that's something else. Okay, so that is a translation. A little bit more information than you probably were used to for a translation. Okay, so we're going to move on and we're going to talk about now rotations. Rotations go about a fixed point, and this point is the center of a set of circles drawn to each point on your original figure, which is kind of confusing. So let me show you a little bit about what I mean, but we'll finish here. The points have been rotated a designated number of degrees along these circles. So let's go take a look here and go back to my Sketchpad file. And now I have a different triangle ABC, and now this is my center of rotation. So I'm going to just make sure and mark that as my center, and it shouts at me and says it is. So we are going to now take this and we're going to rotate about some fixed angle, and I don't want 90 degrees, I want 70 degrees, just because I picked it. And so 70 degrees has taken this figure and rotated it about. Notice that the rotation was in a counterclockwise direction. If I wanted to go clockwise, then I would just put a negative in front of that. And so now a negative direction is a clockwise direction. That is always true in mathematics, is that you default to a counterclockwise rotation unless otherwise designated. So let's go ahead and go the positive 70 degrees and rotate it. And you'll notice again that the labeling follows what we'd expect. And so this is C prime, this is A prime, and this is B prime. And so B has been rotated from here to B prime, A has been rotated from there to A prime, and C has been rotated from there to C prime. And I want to show some hidden things here. These are extra, so I'm going to delete them. They were something from a previous version. So notice that B and B prime are on the exact same circle. And notice that C and C prime are on a different circle, but still the same circle for themselves, along with A and A prime. They're on a third circle. And that can be true about any point that we have here. The point on this triangle that I'm pointing at right now has been rotated along a circle somewhere that ends up on the exact point there. And because I can draw a unique circle for each point with that center at the center of rotation, then I also know again that a rotation preserves angle and preserves distance. Therefore, triangle A prime, B prime, C prime will be congruent to triangle ABC. My justification is because of this idea of circles. Make sure you connect with that idea of circles. If you need to replay it a little bit, please do so. Okay, so rotations, as I said, are about a fixed point. That's called the center of rotation. That center of rotation is the center of a set of circles drawn to each point on the original figure. There are an infinite number of these circles, but they all exist. Those points are rotated a designated number of degrees according to what we decide our rotation to be along those circles. As I mentioned, it preserves the angle and the distance, and so the image is congruent to the original, and we saw that it had the same notation as a translation, meaning that it used the primes. Okay, and so I want to go back here, and I want to show you something that if I go ahead and grab this figure, and we'll ignore those circles for a moment, and transform it again. We'll go with another rotation, and instead of 70 degrees, I want to go with 200 degrees, and it gets behind my little rotation box. And notice again that those points will go to the same marked spot. And so they're on that same circle. It's a new spot now because it's a new angle of rotation. The angle between B, the center of rotation, and what will now also be called B prime because it's translated from the original figure, is a 200-degree angle. The angle from A through the center of rotation to A prime is also a 200-degree angle, along with C through the center of rotation to C prime. Okay, and if I now show you that this is indeed called C prime, just a single prime there because it was rotated off of the original figure, along with B prime and A prime. If I went to grab this figure and rotated that, it's still on that same circle, and I want to rotate it. Let's see, I don't want to rotate this figure. Okay, there we go. And I rotate it 200 degrees, or maybe we'll do a different one. Let's go with 230 degrees, and maybe a little too much, 220. Now it keeps it out of the figure, which is just semantics for me. I didn't want it overlapping over here. So 220 degrees, I rotate it, there it comes, and the main thing that I want to show you here is notice this is C double prime, this is B double prime, and this is A double prime. Notice the two apostrophes right there. Okay, I hope you understand a little bit more about rotation, and if you have questions, feel free to talk about them in class. We will see you when you come back to class. Bye.